Okay, so what do you know about the complex conjugate?
That when it's multiplied with our complex number, it has to be a real number.
That's right. So we have a complex number. So z times z bar, z bar is real. Okay. So just the complex conjugate flips it over the imaginary axis. Okay. But we also know z bar equals z squared here.
So that would mean that z cubed would have to be a real number.
Right, so z cubed is real. Okay. And its conjugate is equal to the square. Okay. So now this tells us that z itself might be real, just to begin with. And so what real numbers, for a real number, the complex conjugate's the same. So then we have the real numbers such that z equals z squared, and you found those already, 0 and 1. Okay. But now something comes into play that's a little more advanced. So I don't expect you to know this, but when you multiply complex numbers, there's an amazing thing that happens, is that their distance from the origins multiply together, which is pretty neat. And we'll learn that later on. But if z is z squared, or z bar is z squared, they're the same distance away from the origin, right? So that distance has to be 1. So if this is a real number, the z cubed either has to be 1 or minus 1 for it to be real. So either we're going to have something that's the cube root of 1 or the cube root of minus 1. Which is pretty neat. And what you found were the cube roots of 1. And in this problem, the cube roots of minus 1 don't work, but they do form the numbers you found, minus 1/2 plus I root 3 over 2. They form a triangle.
Equilateral triangle?
Yeah, they form an equilateral triangle. So there's a lot of symmetry. I haven't drawn it very well. There's a lot of symmetry in this problem. It's a 120-degree angle, 120-degree angle, 120-degree angle. They also, when you multiply complex numbers, their angles add together. So it's pretty neat. So when you square this number, if it's 1 away from the origin, it's 120 degrees, so you got to add the angle. So 120 goes to 240, and it stays the distance of 1 away. So that's how you solve this geometrically. This is a pretty cool problem. It also shows why the cube roots of minus 1 don't work, because when you square this one, it's 60 degrees, so it goes to 120, but that's not the complex conjugate. That's going over the y-axis instead. Good work tonight, man. I like that. I like that problem. Your solution is real nice.